Today, we're going to be talking about 4 key properties of water. Please use your notes to follow along and write down examples as well as definitions as we talk. The 4 key properties of water are shown below: capillary action, surface tension, universal solvent, and specific heat. When you place a straw in a glass of water, have you ever noticed the level of the water in the straw compared to the level in the rest of the glass? Does the level of water in the straw look like the picture A, where the water in the straw is higher than the level of water in the glass? Or picture B, where the water in the straw is lower than the level in the glass? If you said A, you're correct. Capillary action is the combined force of attraction among water molecules with water molecules of surrounding materials. This probably sounds a lot like adhesion. Athletic clothing is a great example of capillary action. When you're playing basketball outside and get all sweaty, your clothes, if you're wearing something like Nike Dry Fit or Under Armour, you won't feel it because that clothing has capillary action and wicks away the moisture from your body. The meniscus in a graduated cylinder is also another example. Capillary action is how plants take in water from their roots and move it up into the rest of the plant. The second key property of water we're going to talk about is surface tension. Surface tension is what we witnessed yesterday during our lab as we saw the skin of water form the dome on top of the mason glass. Surface tension is the tightness across the surface of water caused by polar molecules pulling on one another. If you recall, water is a polar molecule because it has electrically charged areas. Water molecules stick to themselves because they're polar. The negative oxygen is attracted to the positive hydrogen atoms. This is one of my favorite pictures. In this picture, the Olympic swimmer, Tyler Clary, looks like he's completely enveloped in a clear gel as he moves through the pool. It was captured on camera. He's about to break the surface of the water. He seems to be perfectly wrapped in glass because of surface tension. Simply put, all water has a skin, and in the photograph, he's breaking through that layer as he swims the race, which was part of his road to victory in 2012. Here are some examples of surface tension. The water strider takes advantage of surface tension as it walks on the water and feeds on insects. You may watch this video at the end of our lesson. The basilisk, which is also known as the Jesus lizard, has long toes and runs as it travels across the water to avoid predators. Snowmobiles and dirt bikers perform a stunt called skimming. It's unsafe and illegal, but a great example of surface tension. Hydroplaning is also an example of surface tension. When the tire and the surface of the water lose contact and the tire planes or glides on a film of water, that's caused by surface tension. Water is called the universal solvent. It's called the universal solvent because it dissolves so many substances. More substances, in fact, than any other liquid. We call it the universal solvent. Water dissolves solids, liquids, and gases because it's a polar molecule. For example, water can dissolve solids such as sugar, pills, Alka-Seltzer, liquids like bleach or orange juice concentrate. Lastly, it can dissolve gases. For example, carbon dioxide, what makes your sodas nice and fizzy. How can we speed up the dissolving rate if we wanted something like, for example, a sugar cube to dissolve faster? The first thing we could do is crush it. We also can stir it. And lastly, increasing the temperature of the liquid also helps to speed up the dissolving rate. Water is the universal solvent, dissolves road salts and runoff. Think for a minute, how does this apply to our environment? The last example of water properties is specific heat. Specific heat is the amount of heat needed to increase the temperature of a certain mass of a substance by 1 degree Celsius. That sounds very complicated, but for example, specific heat is what causes the water to stay cool when the weather is hot. Water has a very high specific heat. High specific heat keeps water from heating up as quickly as other materials. Land areas near large bodies of water experience less dramatic temperature changes than areas less far inland. In the summer, the sun's heat warms the land more quickly than the water, and the warm land heats the air above it to a higher temperature than the air above it, to a higher temperature than it is in the ocean. As a result, the air inland is warmer than it's on the coast. The opposite occurs in the winter. Land loses heat more quickly than the water, so the air above it is cooler. Imagine your swimming pool. It's 80 degrees outside, and when you jump into your swimming pool, it's nice and refreshing. Just think about this. Temperature of a lake in early June. Definitely chilly, even though it may be in the 70s or even 80s outside. The lake's still cold in June because it takes a lot of energy to warm up a large body of water. After several months of warmth, the temperature in September in that same lake is much warmer. Will it be frozen in November? Not yet. It takes a lot of energy to cool it down. Water heats up slowly, but it also cools down very slowly. In late fall and early winter, the temperatures near the sea and the coast are usually much higher because the oceans are still releasing that stored energy from the summer. This is why so many people flock to live in coastal areas. Predictions? As you can see, coastal temperatures in Virginia are much warmer than temperatures farther inland. The high specific heat of water means the lake won't freeze up or heat up very suddenly. And this is important for the fish and aquatic organisms. It gives them a chance to adjust to temperature changes slowly. Let's take a minute to reflect. Please pause the recording and answer the following questions. When you're finished, check to see how you did. Water can hold heat? True. Some animals can stand or walk on water? True. Water can move up narrow tubes against the force of gravity? True. The abundance of water is a major reason Earth can support life? Also true. Great job. Now go back and watch the videos that we skipped through before you continue the rest of your assignment.